Here is our Sun, a G-type main sequence star located at the center of the solar system. It is the star that Earth and the other planets orbit around, and it is responsible for providing Earth with light and heat. The Sun is about 4.6 billion years old and is expected to continue shining for another 5 billion years before it enters the red giant phase of its life cycle. The Sun is massive. It has a diameter of about 864,000 miles, which is about 109 times the diameter of Earth. It is also about 330,000 times more massive than Earth. The Sun is made up mostly of hydrogen and helium, with trace amounts of heavier elements such as oxygen, carbon, and iron. The Sun is not just a big ball of gas and fire, it is also a dynamic and active star. It has a magnetic field that is about 50 times stronger than Earth's and is constantly producing solar flares and coronal mass ejections, which can send bursts of charged particles and radiation into space. These solar eruptions can sometimes affect Earth and can disrupt satellite and radio communications. The Sun is the main source of energy for life on Earth. It drives the Earth's climate and weather patterns and provides energy for photosynthesis in plants. The Sun's energy is produced through nuclear fusion reactions that take place in its core. These reactions convert hydrogen into helium and release a tremendous amount of energy in the form of light and heat. The Sun is actually moving through space. The Sun and the solar system are part of the Milky Way galaxy, and the whole galaxy is moving through space. The Sun is currently moving at a speed of about 220 kilometers per second, 140 miles per second, and is expected to continue moving in this direction for another 2.5 billion years before reversing course. The Sun has a solar wind that is constantly blowing outward from its surface. This solar wind is a stream of charged particles, mostly protons and electrons, that flows outward from the Sun at speeds of up to 750 kilometers per second, 466 miles per second. The solar wind can sometimes affect Earth and other planets in the solar system, causing auroras and other phenomena. The solar wind is thought to be produced by the Sun's magnetic field, which is about 50 times stronger than Earth's. The Sun has a complex internal structure that is divided into several layers. The core, which is located at the center of the Sun, is the hottest and densest part of the Sun. It is here that nuclear fusion reactions take place, converting hydrogen into helium and releasing a tremendous amount of energy in the form of light and heat. The core is surrounded by the radiative zone, which is a layer of gas that transports energy outward from the core through radiation. Above the radiative zone is the convective zone, which is a layer of gas that transports energy outward from the core through convection. Convection is the process by which hot gas rises and cooler gas sinks, much like how hot air rises in a room and causes the cooler air to sink. The Sun's surface, or photosphere, is the layer of the Sun that we see when we look at it. The photosphere is about 500 kilometers, 310 miles, thick and has a temperature of about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Above the photosphere is the chromosphere, which is a layer of gas that is about 2,000 kilometers, 1,242 miles, thick. The chromosphere is much hotter than the photosphere and has a temperature of about 20,000 degrees Celsius, 36,032 degrees Fahrenheit. The outermost layer of the Sun is the corona, which is a layer of gas that extends out into space. The corona is much hotter than the photosphere and chromosphere, with temperatures reaching up to several million degrees Celsius, several million degrees Fahrenheit. The high temperatures of the corona are thought to be caused by magnetic fields that trap and accelerate charged particles. The Sun's atmosphere is made up of several layers, including the photosphere, chromosphere, and corona. The Sun's atmosphere is important because it is where many of the Sun's most spectacular features occur, such as solar flares and coronal mass ejections. These features are caused by the Sun's magnetic field, which is about 50 times stronger than Earth's. The Sun's magnetic field is created by the Sun's rotation and the movement of charged particles in its interior. The Sun rotates faster at its equator than it does at its poles, which causes the Sun's magnetic field to become twisted and distorted. This distortion can cause the Sun's magnetic field to snap and reconnect, releasing a tremendous amount of energy in the form of solar flares and coronal mass ejections. The Sun's history is closely tied to the history of the solar system. The solar system formed about 4.6 billion years ago from a cloud of gas and dust that collapsed under its own gravity. As the cloud collapsed, it spun faster and flattened into a disc-shaped structure. At the center of the disk, the Sun formed from the densest part of the cloud. As the Sun formed, it began to heat up and eventually ignited nuclear fusion reactions in its core, producing light and heat. As the Sun formed, it also swept up most of the remaining gas and dust in the solar system, leaving only a small fraction of the original mass to form the planets. The Sun and the planets all formed from the same cloud of gas and dust, so they all contain similar amounts of hydrogen and helium. However, the Sun is much more massive than the planets, so it was able to hold on to a much larger fraction of these elements. The Sun has played a crucial role in the development of life on Earth. Without the Sun, life on Earth would not be possible.